PHY2048 multiplied by 2 times 0.45 divided by 0.1 multiplied by 0.7 squared. Well, that gave me a fairly large value. That means the time. Now, I thought my time was very close to 0.9 seconds. Well, if I change that time to 0.9 seconds, well, it gives me about 8. So, well, if I take an average of 0.7 and 0.9, I get 0.8. And that will give me close to 9 meters per second squared. Now remember, what I did is very crude, but you can use this equipment to measure very accurately the value of acceleration due to gravity. So this equipment is now called Atwood's machine because it was used by Atwood to measure the acceleration due to gravity. We will now consider motion of an object placed on an inclined plane. What is an inclined plane? Well, an inclined plane is inclined to the horizontal. Is that right? Here I have an inclined plane. I can change the inclination of the plane to any angle I want, and you can see the angle can be measured here. Well, I'm going to take it and keep it facing me so that you can see the whole of the inclined plane. Now, if an object is placed on a plain horizontal surface, tell me what are the forces acting on this now? You should be able to tell me this. The weight of this block will be acting vertically down. In fact, the force that is pressing the block onto the plane, this is the plane surface, the force that is pressing this block to this surface is the weight of this block. And what does the plane surface do in turn? Apply a force upward. What do you call that force? The normal force. So, if I draw that on the board, it will look like this. Now, this is the plane surface. Let me take off this. Now, if this is the plane surface and here is the block, the weight of the block mg will be acting vertically down, and the plane surface will therefore apply a normal force which will be upward. Now, there is no net force on the object now. Alright, I want you to watch what happens when I tilt this plane. Now this is an inclined plane. Now, the weight of the block now is doing 2 things. What are the 2 things it does? It pulls the block down the plane. That is one part of the weight. The other part is pressing the block onto the surface. And I want you to watch this again. When the inclination is 0, all the weight is pressing the block onto the surface. But when I increase the inclination, well, the weight actually does 2 things. One, part of the weight pulls this block down the plane. Look at that, it's moving. And also it is pressing onto the surface. So the weight now has 2 components. I will draw that as we go on. Now, what are the 2 components? There is one component of the weight acting down the plane like this, and there is another component that will be acting at right angles to the plane like this, pressing the block onto the surface. So, one more time, this weight of this block has a component down the plane and a component at right angles to the plane. Okay, now as you keep on increasing the inclination, the component down the plane will increase and the component pressing the block to the surface will decrease. See that? And finally, when the angle is 90 degrees, you can see all of the weight is moving down. There is no force pressing the block onto the surface at all. So let's quickly do it one more time. When the angle of inclination is 0, all the weight is pressing the two surfaces together. As the inclination increases, the component of the weight down the plane increases and the component pressing the two surfaces decreases. Now you can see the component down the plane increases and the component pressing the two surfaces decreases, and finally when the angle is 90 degrees, all of the weight is pulling it down the plane. There is no force pressing the two surfaces at all. Well, let's now put these things together and look at the theory of inclined plane.